So here I'd like to plot the point 3, 3 pi over 4, and then find 3 other points with the same location. It's important to note that these points that we're plotting are polar coordinates. So polar coordinates. So the first value, 3 pi over 4. This first value, 3, is a directed distance. So I'm going to plot this in blue. So we started the pole and we're going to go out to the third circle to the right because we have a positive 3. So we go to the third circle on the right. This first value, 3, tells us to either go left or right, not up or down, left or right. There is no vertical move, there is a horizontal move. Okay, so we're going to put that there for a second. Now we have an amount of rotation. So if I have a 0 rotation, I would just move to the right or to the left. And then I'm going to go around the circle clockwise are negative rotations, just like we're used to with our unit circle, and counterclockwise are positive rotations. Now, what's a little bit different here is that we're going to be starting our rotations from the x-axis. Sometimes we're going to start those rotations from the positive x-axis and sometimes from the negative. So you'll understand once we find our location and we find 3 other points with that same location. So we go right 1, 2, 3 to the third circle because our directed distance is positive 3. And then we have to turn a rotation of positive 3 pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4. And that's the location of our point 3, 3 pi over 4. Now there's other ways to get to that location. So I'm going to make a couple of different colors. Actually, we'll make 3 different colors for 3 more points. So I could go positive 1, 2, 3 and still have a positive directed distance, but instead of moving counterclockwise, move clockwise. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So that point would be a positive directed distance and then a clockwise move, which would be negative 5 pi over 4. Let me show you that again. One, 2, 3, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Same location, 5 pi over 4. But because we moved clockwise, it's a negative value. Okay, let's get to there a different way. Let's get to there moving a negative directed distance. So negative 1, 2, 3. Now the short way would be a clockwise move, pi over 4. See, clockwise move, pi over 4. So that point right there would be negative 3, and then a clockwise move, that's a negative, and then the amount would be pi over 4. So a negative directed distance would move to the left from the pole, 3 circles, and then a negative rotation means we're moving clockwise, and pi over 4, 1 pi over 4. Same location. I think that I'm hoping that you'll get the idea that there's an infinite number of ways to get to a location with polar coordinates versus with rectangular coordinates. There's only one way to get to a location. With polar coordinates, we could keep going around and around and around and then stop at that point. We want to find points within one full rotation. We don't want to have coterminal rotations. We just want to get that one rotation. And we can find the same point going to the right of the pole or to the left of the pole. So I've already gone to the right twice, a positive and a positive directed distance. Now we're going to do two negative directed distances. So 1, 2, 3, that's a distance of 3 to the left of the pole. And this time I'm going to take the long way around. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So because we went clockwise, that's a positive rotation, and we had to move 7 pi over 4 to get to that point. So that's our first example. Let's have you do a try. In the next video, I'm going to come back and explain where this point is, and then I'll share those 3 other points that have the same exact location.